Morning, my name is Mustafa Attar, chemistry teacher in Omri International School. Today is 13 March. I'll start now grade 11 A, chapter 18, section 3, hydrolysis of acid-base reaction. Hoping you didn't face any problems for the last quiz, I sent to you a quiz to answer it. If you faced any problem, you can send to me to help you. Today we will finish section 3, and as we mentioned before, we have 4 types of hydrolysis of acid-base reactions. The first one is reaction or titration between strong acid and strong base. The second one is reaction or titration between strong acid and weak base. The third one is titration between weak acid and strong base. And the last one is titration between weak acid and weak base. And as we mentioned inside the class and inside the lab, we explained the instruments that we can use during titration. We will use conical flask, we will use burette. This is conical flask and the other is burette. We will add weak or strong base to this conical flask, and it's called now analyte. And also we will add or fill the burette with a strong acid or weak acid, and it's called titrant. So we have 2 solutions, analyte and titrant. And as I mentioned before, the acid-base reaction between strong acid, strong base, and weak acid, weak base, as mentioned here in the color, this reaction is between strong base NaOH and strong acid HCl, or reaction between weak base ammonia solution NH3 and weak acid acetic acid CH3COOH. So we have 2 reactions. The first reaction is between strong acid and strong base. The second reaction is between weak acid and weak base. In this reaction, the result from hydrolysis of the products in water will be neutral, so the pH will be around 7. So in this reaction we will explain the hydrolysis of the Cl minus in the solution, Cl, which is the anion of the strong acid, and cation of the strong base, which is Na. Because you know the reaction between NaOH and HCl will produce salt. This is double displacement reaction, and this reaction between base and acid, the results will be salt plus water. Okay, so we will analyze or study the hydrolysis of the cation Na, which carry positive charge, and the anion Cl, which carry negative charge. And because NaOH is a strong base, the HCl is strong acid, so the anion hydrolysis and the cation hydrolysis are equal. So the overall result of this reaction is neutral solution. So the pH will be around 7. By the same way, for the reaction between weak base NH3 NH3 solution, NH3 present with water. So the solution contains NH4OH. So aqueous solution of ammonia means NH4OH. This will react with weak acid, which is CH3COOH. So the anion of this acid, like HCl, the anion is CH3COH, which will carry negative charge. This is the anion part. And the cation part of this weak base is NH4 positive charge. Also, by the same way like before, the results from the hydrolysis of the weak cation and weak anion will be neutral. So the pH of the solution will be around 7. Now, we finished the first type and the fourth type. Okay? This one is the reaction between weak acid and strong base. So weak acid is analyte, strong base is titrant. So the anion of this weak acid, the anion part is CH3COO minus charge, and the cation part is Na positive charge. The overall result of this reaction will be alkaline solution. Why? Because you have strong base, which will increase the concentration of OH in the solution. So the pH will shift to right side, above 7. So if we explain this curve, we will start with the acetic acid. So the pH is below 7, and you start to add NaOH, but until now you didn't reach to equilibrium or equivalent points. So this area is buffer area or buffer region. At the time of equivalent, the amount of the strong base and the weak acid are equivalent. So the pH will be around 7. Okay? So after that, if you increase the amount of NaOH, the concentration of NaOH will increase. So the amount of OH will increase and the pH will be more than 7. So the net results from this solution will be alkaline solution. So reaction between weak acid or hydrolysis between weak acid and strong base will produce alkaline solution. The last state is the reaction between or titration between strong acid as a titrant and weak base. Strong acid like HCl, weak base like solution of ammonia, NH3 dissolved in water, or NH4OH. It's the same. In this reaction, you will start with the weak base, which is analyte, and you start with aqueous solution of ammonia. So the pH will be alkaline. Okay, and you will add the acid, but this area, like before, is the buffer area until the state of equivalence, the point of equivalence. After that, you will continue to add acid, so the concentration of hydronium ion will increase, so the pH will shift to acidic media. So you can see here the pH is maybe 2 or 3. So the net result from hydrolysis between weak base and strong acid is acidic solution. So the pH will be below 7. This slide is the last slide which explains the calculations in this section. This equation is the acid ionization constant Ka, acid ionization constant, equal concentration of A minus times the concentration of the hydronium ion over the concentration of the HA, which is the reactant. And we will cancel the concentration of H2O as mentioned before, because ionization of water will cancel each other, so H2O is neutral, so it does not affect the calculations. And you can study all these calculations. This is summary or conclusion for all calculations for this section. Hoping to understand this section. Thank you. Bye.